Again, David and I are very, very happy to be with you this evening. David, we said a lot thus far. Maybe we should just stop and make sure we're all on the same page. And to do that, we want to go to the first slide. Something special is found in the black mica specks in granite rock. We've gone over this a little bit so far, but these black granite specks in the granite rock is something that we've said thus far already holds a mystery, a real mystery, of course, that is going to affect a lot of people before it's all over. We were talking about that thus far. And this evidence that we have discussed thus far is in the microscope, seen under the microscope in these black mica specks there in the granite rock. And David, again, we want to make sure we're all on the same page. What is that?
It's a polonium 218 halo. My mic is off. Not sure if that's because I have this off or if because... There we go. Are we on? Okay. Okay. So...
David, this needs to go down.
So we have a 3-ring halo, polonium 218 halo, an isotope of, it has a 3-minute half-life. And the idea is very simple. Like we said last night, if you have a molten rock and you have a theory of granite formation where that rock cools slowly over millions of years, you cannot have that theory and primordial polonium halos. It's that simple. Why? Because if you have primordial polonium halos implanted, the radio centers from that primordial polonium implanted in the rock at the time the rock formed from a melt, by the time the rock cools and crystallizes millions of years later, you've gone way past the 3 minutes or so that the half-life of polonium-18 exists, and you have no record of that halo left in the rock. So the only conclusion you can come up to, if that doesn't work, is to say that that is not primordial polonium, that must be polonium derived from uranium, the uranium decay series. So that is the method, or that is the strategy that most people that do not agree with the polonium halos utilize in their arguments to say that this does not make any sense. They say, well, it must have a secondary source. It has to, because if it doesn't, my whole theory of the age of the earth or the earth formation or granite formation all goes down the drain.
David, you know, we've talked a lot about primordial. That means made in the beginning, doesn't it? That's what primordial
means. Made in the beginning.
Made in the beginning. And so this, what we're talking about is something that had to be of radioactivity, pardon me, made in the beginning. Let's continue. Remember we had this schematic last night where we were talking about something that had a little speck of radioactivity there in the center, and it ejects particles, just microscopic distances in a piece of mica. And as a result of that, just like sun's rays, of course, will bleach objects, colored objects, the radiation from the little tiny speck there will discolor the region around that little tiny speck and produces then a halo. You can see it's three-dimensional. The little particles go out in all directions. But the particles themselves shooting out from that center, 3 different kinds of particles, originate with a kind of radioactivity that exists for only a short period of time. And that short period of time is associated with primordial radioactivity. And as we sort of review of basically what we've come up to make sure we're all on the same page, we have a whole series of these polonium halos. Polonium, of course, is simply a chemical element, but it's radioactive. But it has only a short half-life. It exists for only a short period of time, and then it's gone. And we had this summary slide last night. And David, tell us about the top and then about the bottom of that schematic that we have there to make sure we're all on the same page.
Right. This slide basically just reiterates what we've already said. The top half reiterates what the evolutionary model would predict. If you have slowly cooling granite over long periods of time, you would not have radiohalos because the activity would have decayed long before the record could be left in the rock. if you do have a model of creation where God places the polonium in the rocks, creates the rock with polonium in situ, polonium there already, so that it's leaving a record immediately after the rock has been created, then you have a model which at least fits what we see in the field, what we see under the microscope.
It's important that we understand that what we're dealing with here is something observational. It's not theory. We're seeing these halos in granites all over the world. Primordial polonium halos conflict with what geologists believe about the origin of granite. But we will now see they themselves are barely confused about what they believe. In other words, geologists themselves have said granite forms slowly deep in the earth over a long, long period of time. Go ahead.
I was going to say, I mentioned earlier last night that if you take a geology class, you will learn very quickly that the textbook has a very definite definition of how granite forms. But if you look into it a little bit deeper, you actually see that geologists themselves have varying opinions on how granite forms. And for the reasons why is because you do not see active granite formation. In fact, back in 1947, there was actually a conference that was focusing on the origin of granite. How did granite form? And in this conference...
I just want to add to what you're saying here. We think it would be well for the viewers, audience, to know that indeed, of all things, geologists have been thinking about the origin of granite in the 1800s. They had seen all these granite rocks like El Capitan and others around the world, but they didn't know where the granite came from. Whereas, you know, if you have a volcanic eruption, it erupts and you see the rocks form, that's visual. You know where those rocks came from. But the geologists could not find a place where granite was forming. Isn't that true?
That's right.
They couldn't find that. So they had all these granite rocks all over the world, but they didn't know where they came from. So they had to invent. That's really the word they did. They invented the idea that the granites must have formed, isn't it true, out of sight.
Right.
And so out of sight, they figured, well, at one time it was hot down in the earth, well, really, really, really hot. We know it is hot down there further on. But there was a huge melt, and gradually over a period of time, it what? Cooled and went to a solid. Now, though, David, we're going to find out how well do they really know what they were talking about. You were going ahead.
Let's look at the next slide here. This is actually a quote from F. Fitz Osborne, I think is what the next slide is going to say. But anyway, in this quote, he says, "Mr. Chairman, ladies and gentlemen, it is a pleasure to take a part in a discussion of this sort for two reasons. In the first place, the newspapers and the radio are bringing problems before us every day, and they are threatening dire consequences if we do not solve them. In this symposium, we are treating a problem that is really an old friend. This problem goes back through almost all the years during which there has been a science of geology. We have never satisfied ourselves as to the solution, and we furthermore must note that no very serious consequences arise if we do not arrive at that solution." F. Fitz Osborne. What is that problem that is really an old friend? The problem is, how did granite form? And I mentioned briefly last night, there's another quote, we can go ahead and look at that too, that we're saying, you know, if granite formed naturally, you should be able to form it in the laboratory today. Well, people say, well, wait a minute. We're theorizing that granite forms slowly over millions of years. How could we ever devise a laboratory experiment that would last millions of years for the granite to slowly cool? And I'll give you a chance to think about that a little bit more. We'll talk about it when we show a slide later that actually shows a result from an experiment where granite was attempted to be synthesized in the laboratory. A.E.J. Engel, U.S. Geological Survey, said this: "The appeal has been made repeatedly for an objective approach to the problem of origin of granite." The problem is the origin of granite, with careful and restrained use of the attractive hypotheses. But they're not susceptible to proof. Why are they not susceptible to proof? Because you can't actually see the granite forming. It's miles underneath the Earth's surface. If exposed to continued testing, that's an important point in science. You have to test your views. Our points of view, like whiskey, will doubtless change and improve with age.
David,
That's the hope.
David, we want to remind ourselves and everyone, of course, this was an Origin of Granite symposium, I believe, held in 1947. And geologists have been thinking about the origin of granite for 150 years. But here in 1947, they were saying these things to one another. They're basically admitting, not realizing that later on we were going to find what they say and bring it out here tonight, how uncertain they were at that time. Have things changed at all? 1947. A lot of things have happened in the last 50 or more years. Let's see what else is going to happen. Well, now, there's another one here, says it was taking place in 1988. What happened?
Right. So a little more recently than 1947, 1988, there was another conference on the origin of granite. And a quote here by Professor W.S. Fife from the University of Western Ontario says, as was well documented by the discussion during this meeting, many, old questions are still debated. But I think we now have the tools to resolve many of the basic questions. I would certainly hope that 100 years hence, we will not be debating the origins of granite. The thing we're really trying to stress here and get across that we're coming up here and proposing a very radical idea. And that idea is that granite rock was part of the original created rock. You know, from a scientific point of view, that doesn't make any sense. You don't make scientific hypotheses based on something being created by God. That's something that's out of the realm of science. That's something that's in the realm of religion. But just hold on for a minute. Look at what the scientists say themselves about the origin of granite. They don't even know how really it formed. It's a mystery. And in fact, when you actually do the experiment to test whether the theory of granite formation actually works in the laboratory, it comes up far short of a granite. You actually come up with a rock that's called a rhyolite. But we'll look at that when we get to it. But go ahead and
David,
keep going here. And
we're talking about some exciting things. We're talking about something that basically overthrows a major discipline of science, of geology, that thousands and tens of thousands and hundreds of thousands of geologists have believed, and millions of scientists in the world still believe it. And we're standing up here tonight and saying, indeed, fellas, you've got it all wrong. Look at that last sentence there. This man, Professor W. Fife, the last statement says, I would certainly hope that 100 years hence we will not be debating the origin of granite. Does that sound like to you that he's really got a realistic expectation that they're going to be able to explain
Yeah, I don't
them?
think so.
Can you imagine if the people in the world really understood, if even the science students, geologists going through the curriculum, really understood the tremendous uncertainties of what they learn in the classroom about the origin of granite, the origin of the earth, and going along with that, the age of the earth, and not only the age of the earth, the age of the cosmos. We're dealing with material here tonight, with ideas, with scientific data and the Bible, that literally, if understood, and that's why we're here tonight, to help people understand and get it out to the world, this is going to revolutionize. I'm not ashamed to say that in God's great providence it is going to happen, and there's going to be a revolution of some sorts. So we better be prepared. Anyway, that was back in 1988 where that symposium was occurring. But you know, the geologists didn't stop trying to explain granites at that time. Guess what happened?
Let me have that clicker.
Anyway, I'm getting carried away, aren't I? It's okay. Several years later, in the 90s, there was another symposium. Really, really thick. Thousands of experiments are being done. And again, Fourth Hutton Symposium on the origin of granite. No granite forming. Thousands of pages again. Then we got another one here, the early 2000s. Fifth Hutton Symposium on the origin of granite and related rocks. Still, thousands of geologists are working night and day for years and decades, now a century or more. And still no origin.
But I think it's important to say that when you go to the classroom and to even the college classroom, the idea that there's any kind of argument or uncertainty about the theory of how granite forms is not really conveyed in the textbooks. So the students really aren't getting any of the full picture of, saying, well, hey, there are, a lot of uncertainties about what we